Okay, students, Assalamu alaikum. So today we are going to start the most awaited topic in physics, that is space physics. So today we are going to solve the MCQs related to the topic of space physics, which is newly included in IGCSE and O levels both 50540625. So let's start with the topic. And I already explained all the concepts related to space physics on my channel. So you may check out my playlist for the space physics. I think there are total six videos related to the space physics in which the life cycle of a star, the redshift, and basic concepts related to moon, what is the difference between planet, star, galaxy, satellite. All this content was already recorded and uploaded on the on my channel on the playlist of space physics, so you may check out over there. So today we are going to solve MCQs related to space physics only. So starting from the question one, which row in the table correctly list a galaxy, planet, and a star? So you just need to only identify the type of what is galaxy and which example is the or which is the name of galaxy mentioned in the table, and what is a planet and which one is a star in the given option. So starting from the star and planet, because we know about a star and planet that we already studied in general science if you not studied the space physics till now. So if we talk about the star, so we know that sun is a star. So it means option B or C is possible. A and D is not possible, right? So it means we need to choose between B and C. So we know sun is a star. And if we talk about planets, so Earth and Mars both are planets, okay. And if we talk about galaxy, so now choice is very simple. Milky Way is a galaxy because solar system is not a galaxy. So option B is the right choice. Very simple question, right? Question number two is the orbit around the sun of a comet is not circular, which is pretty clear from the diagram that the diagram or the circle around the sun is not clear. So the distance between the sun and the comet varies as shown in the diagram. Where in the orbit is the speed of the comet? So basically they are talking about where in the orbit is the speed of comet the greatest and where is the smallest. So you need to find out that where will be the speed of the comet is greatest and the lowest. So we know that if we talking about the distance, so at point R, the distance between sun and comet is very less as compared to the distance between point P and Q from the sun. So you may easily observe the distance between these points as compared to the distance between other point between the sun. So the greatest distance is from P to sun and the smallest distance is from R to sun. And Q is in the mid between R and P. And the rotation is just like anti-clockwise, because if we move in alphabetical order, so comet is rotating or orbiting in the position from P to Q, then Q to R. Okay. So this is the type of rotation or the direction of rotation, because we can easily identify with the help of the alphabetical order. So now we need to find where will be the speed greatest and where will be the speed the smallest. So if we talk about the distance, so what is the importance of the distance from the sun? Why they are talking about the distance? So we know the concept. If we talk about the distance or if we compare it with the speed, so basically, when the planet or the comet is very close to the sun, so you know that there is a concept of gravitational field. So when we are close to another planet, so there will be a greater or the gravitational field will be greatest. So that's why speed will increase. So when any other planet is close to some other planet, so there will be a greatest speed for that planet. And if that planet is away from the sun or any other planet, so speed will be lower because of less gravitational field or a weak gravitational field. So by using that concept, we can easily identify that speed will be greatest at R. So speed will be greatest at R and speed will be lower at point P, because P is the greatest distance from the sun as compared to Q and R. So right option will be speed greatest at R and speed is smallest at P. That is option D. Simple concept of gravitational strength or force of attraction between planets. Okay, question number 3, the orbit around the sun of a particular asteroid. Now again, the same diagram, the same concept. The distance between the sun and the asteroid varies as shown in the diagram. Now they are talking about a specific type of energy that we need to identify, that where will be the gravitational potential energy greater and where will be the kinetic energy will be greater or less. Or maybe some type they are talking about, or they may be asked something like that. So again, we can see that x, y, z. So again, the rotation is anti-clockwise because of alphabetical order x, y, z. Now we need to find out which energy transfer takes place as the asteroid moves from x to y and y to z. So basically, they are talking about between 2 points x to y and y to z. So we know that when the asteroid is closest to the sun, again the same point z is closest to the sun. So we know that speed will be greatest. So when we are talking about the closest distance, so speed will be greatest. And speed will be greatest mean if we compare with the formula of the kinetic energy and the potential energy. So the formula for the kinetic energy is half mv square, and the formula for potential energy will be equal to mgh. So according to that, we can easily compare that speed basically concerned with the formula of kinetic energy. And if we increase the speed, so kinetic energy will automatically increase. So that gives you the hint that at point Z, kinetic energy will be greatest, right? So when we are moving from Y to Z, so it means that our kinetic energy is going to be increased, right? And when we are moving from x to y, so it means that at point x, there will be a greatest potential energy. And when we are moving close towards the planet, so it means our energy is going to be converted from potential energy to kinetic energy. Because of that difference of speed, we easily compare with the formula of kinetic energy and potential energy. So according to that, when we are moving from x to y, so gravitational potential energy is converting into kinetic. And further, if we move from y to z, again our remaining gravitational potential energy will more convert into the kinetic energy. So it means option A is the right choice. As close you start moving towards the planet, so your energy is going to be convert from potential to kinetic energy. And as far as you move away from any other planet, so your energy is going to be convert from kinetic to potential. So when we are moving close to the planet, so close to the planet means kinetic energy will increase. And if we are moving away from the planet, because you know that there is a gravitational field, and if you take the example of a rubber band, so if you stretch the rubber band, so the length of rubber band will increase and elastic energy stored in it. Same goes for the planet. If planet starts moving away from some other planet, so there is a force of attraction over there, and due to that attraction or force of attraction, there will be a potential energy. So when we are moving away, so potential energy is going to be increased for that specific planet. I hope that makes sense and very easy. Okay, question number 4. Ceres and Vesta are two asteroids. Now again, they are talking about asteroids. The orbits of Ceres and Vesta are approximately circular. Okay, now they are talking about circular shape. Let's check out other statement. The gravitational field strength at the orbit of Ceres is weaker. So now they are talking about the sun's gravitational field. Again, the situation is same. They both are moving around the sun. So in the orbit of Ceres, it is weaker as compared to the orbit of Vesta, right? So it means that at Ceres, the gravitational field is, or the gravitational field strength of Sun is weaker, and the gravitational field strength of Sun is greater, right? And the question is, how does the orbital speed of the Ceres and its orbital period compare with the orbital speed and the orbital period of Vesta? So now you need to compare the orbital speed and orbital time period of Ceres with Vesta, right? So in option, you see that there are two columns which is related to the orbital speed of Ceres and orbital period of Ceres. So according to that, we know that the gravitational field is weaker. So we know that it is far away from the sun. Again, the same concept from question number 1 and 2, and it is close to the sun. Vesta is close to the sun and Ceres is away from the sun. So we know that when Ceres is away from the sun, so its speed will be less as compared to Vesta. Smaller, so it means we need to choose smaller. So option C and D is not possible. we need to choose smaller, because we know that Ceres is away. So again, same concept, because when we are close to the planet, so there will be a greatest speed, and if we are away from the planet, there will be less speed. So that's why Ceres have less orbital speed as compared to uh, Vesta. And if we talk about the orbital time period, so we know that when speed is slow, and if we compare it with the formula of orbital velocity, so formula is 2 pi r over t. So if we talk about the time period, so if speed is smaller, so speed is smaller means v is inversely proportional to time period. So it means that if a speed is smaller, so time period will definitely be greater. So, and you can simply imagine that if one man is moving, walking from one point to another, and other one is driving from one point to another, so definitely the man who is in a car will move faster as compared to the man who is walking. So same goes for the planet. If the speed is very much slow, so it will take more time to orbit around the sun. So with the concept of speed and time period, we can easily say that the orbital speed of Ceres is smaller than Vesta, but the time period will be greater because of less speed. Now let's check out question number 5. The sun emits energy in the form of electromagnetic radiation. We know that sun emits energy in the form of radiations. Which three components of electromagnetic spectrum account for almost all of this energy? So you need to identify all type of electromagnetic radiations that are going to be emitted from the sun, right? So let's check out first option: infrared, microwave, ultraviolet. We know that microwave we used in our daily life for the transmission between satellite and Earth. So microwave is not the right choice. And option B, again microwave. So microwave again not possible. And in D, microwave is also not possible, because microwave we used in our daily life for the signal transmission between satellite. So C is the right choice: infrared, ultraviolet, visible light. This is the right choice. And you may check out from my lecture also. All lectures, all topics are explained in detail over there. Question number 6. When in the life cycle of a star are heavy elements produced? So we know that first we are having a stable form of a star, that is protostar. This is the stable form of the star. And we know that we studied the life cycle of a star. We already discussed the questions related to the space physics for P2. We already discussed about the lectures related to space physics, and according to that we know that protostar is the some type, we can say that the stable state of the star. And now they are talking about the heavy elements produced. So heavy elements produced when a star is in unstable form, or it is going to be there will be some type of a blast or explosion over there, which happens when the star is going to be convert from stable state to unstable state. So that happens when there will be a supergiant explode. If you don't know about the process, so you may check out my video again. I am again and again reminding you. Otherwise, you just check out the short video which was already uploaded on my channel, which is related to the life cycle of a star. So that will also help you. That video is for 1 minute. That will give you the idea that how a star is going to be explode. So by name you can easily identify when a red supergiant explodes. So when supergiant explodes, so then due to this explosion, the star is going to be converted into heavy elements, right? So C is the right choice. Okay, question 7 is related to the life cycle of a star. This question is type of a puzzle. So you just need to arrange all the process. So we know the process: protostar is the stable form, then it will convert into a supergiant, then supergiant explodes, it convert into uh, some other form like dark planets, black holes, nebula. These are the all process which is related to the space physics concept related to the life cycle of a star. So in question number 7, we need to arrange the order from first to last. So the very first concept is a cloud containing hydrogen collapse due to gravitational attraction, because when there is a fission reaction on a star and there is a gravitational field, so gravitational field tries to attract towards the center, but fission reaction uh, emit radiation in the opposite direction. So that is the stable state because both forces are in the opposite direction. And due to equal and opposite direction, star will be in a stable state. But when fission reaction is running out, this is due to the fission reaction, because we know that hydrogen is the fuel for fission reaction. And when fission reaction is going to be running out, or hydrogen is going to be running out, because hydrogen is a type of a fuel for our fission reaction. So we know that when fission reaction will be weak, so there will be a strong gravitational pull towards the center. And due to that strong gravitational pull towards the center, right? So there will be a fusion reaction to produce, we know that starting fission reaction, sorry, not fission, fusion reaction, because on a star, we know that, or on a sun, there is a fusion reaction. Sorry, my mistake. Just correct this term. It is not fission, it is fusion, because stars and all other planets, just like the star or the sun, both or these type of star are formed due to fusion reaction. And hydrogen helps to start or to continue the process of fusion reaction. But when hydrogen is running out, or we can say that the fuel for the fusion reaction is running out, so this hydrogen is going to be converted into helium. So first, uh, we need to choose from these options what will be the first process. So J is the first process. A cloud containing hydrogen collapse due to gravitational attraction, because when hydrogen is running out, so it is going to be collapsed due to gravitational force which is acting towards the center. And the next process is, when hydrogen is going to be perform fusion reaction, so it converts into the helium. And then helium, because we know that in fusion reaction daughter nuclei is combined to form parent nuclei. So in parent nuclei we are getting helium. So when we are getting helium, so after hydrogen, helium continue the fusion process for some time. But after that, after some time, helium will also run out, and then there will be a giant explosion, and then that giant explosion will convert into black hole and dark planets. So M is the second process, and after that, we have two choices. We know that there will be a giant star. So K will be the third process and L will be the fourth process. So according to that, A will be the right choice. So before solving these MCQs, I recommend you to first check out the videos for this topic, then try to solve the question, because the weightage of this chapter is not much greater as compared to the other chapter. So after solving all the topicals, then try to understand the topic of space physics and then solve the questions. What provides the evidence for the Big Bang theory? So in Big Bang theory, we know the concept. We provide evidence with the help of redshift. And redshift, I already explained many times about redshift, that helps you to identify. Redshift means the red color. And if you remember the concept of electromagnetic spectrum, so in electromagnetic spectrum, red color basically represents the greater wavelength. And greater wavelength means when galaxies are moving away. So when galaxies are moving away from the planets, so there will be a red shift because of greater wavelength. Again, you remember the concept of that sound source which is going to be produced. Let's suppose there is a sound source and there is a listener over here, and there is also a listener over here, and sound source is going to be moved towards right hand side. Let's suppose if we are talking about ambulance, so let's suppose ambulance is moving towards listener one. So the sound waves are which is going to be generate around the sound source will be like this. So waves are going to be shrink towards right hand side, but waves are going to be expand towards left hand side. And if we compare the wavelength, so we can easily compare that this wavelength is greater as compared to these wavelength, because these wavelengths are smaller. So when source is moving away from the second listener or any listener, so wavelength will be greater. So same goes for the galaxies and planets. When galaxies are moving away, so their wavelength will be greater, and according to the greater wavelength, we know that the red color has the greatest wavelength. So that's why we use the term of redshift. So according to that, uh, the expulsion of heavy element, A option is not possible. B option, the increase in the observed wavelength of radiation emitted by the distant galaxy. So basically this is the evidence because that is related to the redshift. So B is the right choice. And this concept is known as the Doppler effect. I already explained many times. So please, I recommend you to check out my lecture before doing these questions. Maybe they help you to solve question and got the concept in a better way. Question number 9, radioactive isotope emits three type of radiation, which list gives the type of radiation in order of their ionizing effect from greatest to latest. Actually, this question is most related to uh, the nuclear section. So we need to find out with respect to the ionizing effect from greatest to least. So we know that the ionizing power of alpha is greatest among all alpha, beta, and gamma, and the ionizing power of gamma is the least. So for question number 9, alpha, beta, gamma is the right choice. Option A. Question number 10 is also related to nuclear, so that we already solved because that is the definition of half-life. Question number 11, light from the sun travels to the earth at a speed of 3 exponent 8. So this is the speed, and this journey takes almost 500 seconds. This is the time. And what is the average orbital speed of the earth in its orbit around the sun? So we need to calculate the orbital speed, that is v, right? So we need to calculate the orbital speed, and you remember the formula of the orbital speed, that is 2 pi r over t. So let's try to solve by using that formula. So according to that formula, let's try to solve the question. So the formula for the orbital speed basically equals to V is equals to 2 pi r, the distance, divided by the time period. Time period basically the time takes by a planet, that is time taken by Earth to orbit around the sun. So first of all, we need to find the distance because distance is unknown. They only mention that light takes 500 seconds to reach from sun to the Earth. So first we need to find out the distance. So formula for the distance is, we are considering distance as r, the distance between the planet, and formula for the distance is equals to v into t. So speed will be equal to 3 exponent 8, which is already mentioned, and multiply by the speed. Sorry, the time is equals to 500 seconds. So distance will be equal to 1.5 exponent 11 meters. So this is the distance between the sun and the earth. Now next step is we need to find out the average speed. So sorry, or average orbital speed. So for orbital speed, we use the formula 2 pi r over t. So we know 2 pi is the constant, r we already calculated, and the time period is 365 days because earth takes 365 days to complete its orbit around the sun. So according to that, we need to take 365 days. So we just need to write 2 pi r divided by 365 into 24 hours and 24 hours into 3600 seconds because we need to convert time into seconds. So calculation will be like this: 2 pi r will be equal to 1.5 exponent 11 finally divided by finally we need to divide it by the time period. Time period will be equal to 365 days, and in 1 days there are 24 hours, and in 1 hour there are 3600 seconds. So by calculating the value, we will get the final answer that will be equal to the orbital speed, that is the average orbital speed. So the average orbital speed will be equal to 2885.7 meter. So that is the average orbital speed. But if we take the answer from the given option, so we just need to round it off. So by rounding it off, we will get the answer 30000 meter. That means 3.0 exponent 4. So option C is the right choice. Okay. So that is also a good question related to the space physics. And that is, I think, I already solved in specimen, I think 5054. So those who already solved those questions, those know that how to solve this question. Okay, now let's moving towards the next question. That is question number 12. In the sun, energy is transferred from an energy store. Which energy is being released and what is the name of the reaction that releases this energy inside the sun? Now they are talking about the sun. So in sun, we know that we already discussed that there is a nuclear energy and that nuclear energy produced due to the fusion reaction. So D is the right choice for question number 12. Question number 13. The light emitted from a galaxy is redshifted when detected on Earth. Again, the same concept related to redshift. How does the frequency of the light when detected on the Earth compare with the frequency when emitted and in which direction the galaxy moving? So they are talking about the galaxy, movement of the galaxy and frequency of the light compare with the frequency when emitted and in what direction is galaxy moving. So we know that in redshift galaxies are moving away, right? Again, the concept of redshift, we already know the concept. So by using that same concept, so we know that frequency will be less because when wavelength will be greater, frequency is going to be decreased. Both are inversely proportional. So we know that there are two options related to less frequency, that either option A or option B. So we need to choose from this. But we know that when galaxies are moving away, so wavelength will be greater. So that means option A is the right choice because in option A, they mentioned that they are moving away. So away is the concept related to the redshift and wavelength will be greater. And when wavelength will be greater, so frequency will be less. We already discussed that concept in the chapter of waves, right? So you know the concept. So option A is the right choice. Let's moving towards the next question. Okay, which row in the table describe the process? Again, the same question, which is related to nuclear fission and identifies the change in the total mass of the particle involved. So process, they are talking about the process of nuclear fusion. So in nuclear fusion, we know that daughter nuclei are going to be combined to form a parent nuclei. So two small nuclei will combine. A and B is not possible because they are talking about the split of the nuclei, that is fission reaction. So two small nuclei combine, and when they are talking about the total mass, so what will be the total mass? Mass will increase or decrease? So mass will decrease because there is a nuclear fission or fusion reaction. We know that there will be a release of energy, and when energy is going to be released, so it means that mass is going to be decreased over there, just like the sun, because sun is also going to be decrease its mass day by day because of explosion, and many particles are going to be emit out from the sun. So that's why mass is going to be decreased for that particle also. So C is the right choice. Again, the question is related to the orbital speed. The orbit of moon around the earth is modeled as a circular path of the radius. This is the distance or the radius. Now we already have a value of r. Now we don't need to calculate the value of r. And there is a time of 710 hours. This is the orbital time period. So that is capital T. That is simple, straightforward question related to the orbital speed. 2 pi r over t. And the most interesting thing in this question is that you don't need to convert the SI unit because answer is in kilometer per hour. And we are having values kilometer and r. So we just need to substitute the value. 2 pi r will be equal to 3.8 exponent 5 divided by the time. Time will be equal to 710 hours. 710 hours is the total time. And we just need to multiply and divide. So you will get the answer. And the answer will be equal to option D. You may perform calculation and you will get the same answer after rounding off. We already solved this question in a specimen. So that's why I'm just moving fast through these questions. Which statement does not describe redshift? Again, the question related to redshift. And in redshift, we know that galaxies are moving away, the most important thing. And second important thing is wavelength will increase. And third important thing, frequency will decrease. So these are the important point related to redshift. So when they are talking about redshift, because now we are only solving MCQs, so we don't need to write in detail. So that is very plus point. So we just need to memorize the key points. So in question number 16, which statement does not describe? So let's check out this statement. First statement, all the light emitted from all distant galaxies is at the red end. So basically they are not talking about the red end of the spectrum. Basically redshift is taken from the concept of the spectrum, but that never describe related to the spectrum, because in redshift we never discuss about the spectrum. We only take the reference of red and blue color, just like the electromagnetic spectrum, but that never explains that galaxies is at the red end of the spectrum. Okay, so it means statement A, the first statement is not correct. It means this is the right choice because we need to select the wrong statement. And let's check out the other. The light arriving at the earth from the receding star is always redshifted. Yes, because the stars are moving away from the planet, so there will be redshifted. During redshift, wavelength will observe is longer, so that is also correct, greater wavelength. The light from the star in all distant galaxies is moved toward the red end of the spectrum, so that is right. So all light emitted from the distant galaxies is at the red end of the spectrum. That is not right, because when we are talking moving away or towards, so then you need to identify redshift or blue shift. But it never means that it will always at the red end of the spectrum. It depends upon the distance, either they are moving close or moving away. Question number 17. The energy generated in stable stars come from nuclear reactions. Which type of reaction occurs in the sun? Again, the same concept. We already studied about the life cycle of stars. So sun is also a type of star. So you just apply the same concept on the sun. So in question number 17, we know that hydrogen nuclei join to form helium, because hydrogen is the fuel for the fusion reaction on sun or star, and then it converts into helium. Very simple. Two quantities define the Hubble constant. Basically, this is related to Hubble constant, and the formula for Hubble constant is speed is equals to Hubble constant multiplied by the distance. So they already mentioned the speed at which the galaxy is moving away from the Earth v, the distance of the galaxy from the Earth d. So h naught is the constant. So you just need to memorize the constant value. You just need to identify the constant value. So the constant value is always equal to 2.2 exponent minus 18 per second, and we know that v is directly proportional to d if we take h naught constant, right? So that is the easy concept. So v is directly proportional to d, and h naught is a constant value, so you always need to just memorize or get the hint of this value, 2.2 exponent minus 18 per second. Option B, the value is same but the sequence is not right, because v is directly proportional to d, not inversely. And in other two options, these values are related to the speed of light. You can easily identify. So that's not difficult. Last but not the least, approximately how long does it take for the moon to make one complete orbit of the Earth? So you just need to write about the moon. That moon will take 1 month to complete orbit around the Earth. So that's very simple. Option B. Okay, so these are the questions related to the space physics, the most demanding MCQs and the topic. Okay, so after that we completed all topicals and all videos are uploaded. So just go through the topicals, and after, and I guaranteed you, if you just go through my all topicals video, so after that if you don't solve any yearly paper, so you inshallah will get good results in your exam. So because all questions that is those are included in my topicals are taken from the past papers, because when we are solving topical, so we are focused on a single topic, and that will help you to solve questions very quickly. And once you solve all the topicals, so after that when you are going to solve the yearly papers, so that will be the same question, because we already solve in topicals. Just you need to solve yearly paper to uh, check out the time that how long you will take, you are going to solve the question. So to manage the time period, you solve those yearly papers. Otherwise all questions are related and mentioned in our topicals. I hope this will help you. So spread this link of this video and other videos to your friends and your colleagues also, so they will also get access to these questions of space physics and the concept of space physics, because I know that most of the students don't have any idea about space physics and how to solve space physics. So inshallah, tomorrow we again solve some yearly paper, and till now practice these questions and let me know if you find anything difficult. Take care. Allah Hafiz.